Hello, this is Tommy. Welcome back to Chatomics. So in today's video, I'm going to show you how to practically lift over a bedpe file from hg19 version to hg38 version. Okay, so what is a bedpe file? So if you know what is a bed file, and you can easily understand what is a bedpe file. So bed file is defined minimally by 3 columns: so chromosome, start, and end. So usually we use that to denote a genomic region or location in the genome. And the bedpe file is just a file format to denote actually 2 genomic regions. So let me show you the file that we're going to use for today's demo. So this is just a bedpe file. This is from ENCODE, and it shows the 2 genomic regions that are interacting with each other. So you have chromosome A, start A, end A, and have chromosome B, start and end. So in this file denotes, okay, this genomic region is interacting with this genomic region. So usually those type of data can be obtained from the interaction data such as Hi-C or Hi-Chip. So those type of data. So I will give this link in the description of this video so you can download the same file and follow the tutorial. So in this case, this file is in hg19 version, and I want to lift it over to hg38 version. So how do you do that? In R. So let me show you. Okay, so we will use the liftover function actually in R, but we need to actually have this chain file from UCSC genome browser. Essentially, that chain file maps 2 versions of genome, hg19 versus hg38. So the coordinates in one genome, where do they actually map to the other reference genome, right? Okay, let's load the libraries, track layer for importing bedpe files, and annotation hub, which contains a lot of actually annotation files. One of them will be the chain file that we're going to use. Okay, so let's run them, and then we can take a look the chain files, because we are actually defined the data class to be chain file and species be human, and then we can query the hub, and let's look at hg19 and hg38, and those are the files that are available. So you have hg38 to hg19, that chain file, or vice versa, hg19 to hg38 chain file. Okay, and we need this file because the bedpe file we have is hg19. We want to map it to hg38 version. So let's do that, and let's get that chain file. Okay, so essentially this is the chain of length 25. So 25 actually a chromosome here, XY, and also chromosome M, mitochondrial. Okay, so you can look at the function lift over here. So this is from the R-track layer package. It is used to lift intervals or genomic regions between different genome builds, hg19 to hg38. And it needs this chain file we just actually get from the annotation hub. Okay, now let's actually read in the bedpe file using the import function. So import is also from the R-track layer package. It can import bed files and many big files and many regularly used genomic files into R. And you can look at import actually. So we'll be in the R-track layer. So it has, you can import many different formats, BAM files, right? Or bed files, all those different formats. Okay, so now we're using this to import the bedpe file. So this is the file that we already downloaded here from this repository. And let's see whether I can import it. Oh, there's something wrong. And it's just very normal to get error messages, but to read the error messages carefully. It says, okay, scan, expect an integer, but you got stop A. Okay, let's see. And I already downloaded it here. So if you look at here, indeed, the first row is the header, and this actually gives you the error. So we need to actually get rid of the header. And I believe in this file there are actually multiple rows. We start with chromosome A. We can do that. Say grab chromosome A, and you see there actually those are the rows that start with this header. So let's actually remove them. So grab -v, and it will actually remove those rows that has pattern chromosome A. So let's save it to encode enhancer promoter interaction clean .bedpe. So now we have a clean file without those comment lines. Okay. Now we can read it into R. So change the name here. Okay, let's see. Now it's, if you look at bedpe, it is a pairs object with actually almost 600,000 rows. Okay, so this is the first genomic ranges, and this is the second genomic ranges. Okay, it's the same as we see here. Okay, two regions. Okay, and you can use this @ sign to access the first pair, and this is the second pair. So if you use the @ sign to give you the genomic ranges for the first pair, and then you can do the same thing for the second. Okay, now we can lift it over using the lift over function. So for those two regions separately. Okay, so you can do lift over, then this is the first region, and then specify the chain hg19 to hg38 chain. So let's do that, and then let's do for the second pair as well. So ideally, okay, now you lift it over, then you just put them back. Now you get a bedpe file that is lifted over to hg38 version, but there are some nuances here. Okay, because there are regions in the hg19 mapped to multiple regions of hg38, and also there are some hg19 regions do not map to any regions of hg38, so it will be empty. So for example, if you look at here, so this will be lift over, so we can look at the number of, so if you look at this, it's a genomic ranges list object. If you look at here, so it's a genomic ranges list object, and some of them will have multiple entries because one region in hg19 mapped to multiple region of hg38. So you can use this elements and rows for this. So you essentially see how many of them have more than one regions, like after you lift over. So if you look at this index, and you can use index to subset lift over version, then if you look at this and you see those are the entries that with multiple regions. You see, for example, you have 3 for this one, and you also have 3 for this one. Okay, and there are also some regions that do not map to any hg38, so you can use the same function element and rows, and this genomic range list equals to 0, so some of them will be empty. So if you look at that, you do have 84 regions that do not map to any hg38. Let's take a look for the second pair as well. You have 156 actually regions in the second pair that do not map to any hg38 version. So if you look at the lengths, so those are the same length. Okay, now we should actually first remove the entries that do not have any mapping in hg38. So we use the which function to get the index. So use this equals to 0 and get the index for the first pair, and then get the index for the second pair that do not have any mappings to the hg38. Okay, so okay, the valid index, so for example, if you look at the index here, okay, those are the index. Now we can get the total valid index will be, okay, set diff, okay, this index and this index, concatenate them together, and this is the total index, and let's do the set diff, so only get the valid index here. Now we can actually remove those invalid ones. So first lift over, then we just use the valid index to subset the original one. Okay. Okay, now we removed all the pairs that do not have any mappings. So now we need to deal with the pairs that have multiple entries. Okay. Okay. Let's actually take a look at which indexes are the ones that have more than one entry. So the same thing, use the which command, get the index, and this is the essentially the condition that we are checking. So the elements, number of rows, and greater than 1. So get that. Do the same thing for the second pair. And now we have a little function to select the entries. Okay, because for example here we have multiple, let's see, for example, we have this, and now index 1. So those ones have multiple entries here, and we just want to select one of them with the maximum length. Okay, so width, essentially, the width of that number of ranges. So we only want to keep one of them, which is the longest one. Okay, so this is how we use this function. So if a genomic range, if there's more than one, and we need to return the one has the greatest width. Okay, now we can actually just loop over the ones with more than one entries and select the valid region which has the most actually length, okay, the longest one. So you can do this. So you can actually take a look at how many of them have more than one entries. So you have 8,000 something here, and then look at this, you also have 8,000 something. Okay, so now you can use this apply function. Remember, this is the genomic ranges list, so you can use the apply to apply a function to each element of the list. Okay, so actually we're not going to use the apply because it will give you a list, but it's not a genomic range list object. So to actually maintain the genomic ranges object class, you use this endo apply function, and the same actually arguments here. So the first lift over index 1 and select valid regions. Okay, and you can, so once you do that, you unlist it, and it will become just genomic ranges. And this is the first lift over, then you have the minus index 1, so those are the valid ones. So for example, we can do that. So those are all the valid ones. It's still a genomic ranges object, but if we do unlist, it will become a genomic ranges list. So it will become a genomic range object. Okay, so we can do that for the first pair. See, I select the Oh, so we need to run this, and then let's do that. It takes a little bit time actually, because we have 8,000 row that has multiple entries, and we are only selecting the ones with the longest width. Okay, we will do the same thing for the second pair. Okay, takes a couple minutes. Okay, it's done. So now we actually lift over the first pair and the second pair, and also remove the ones that do not have any mappings, and only take one entry for the ones that have multiple mappings. So if you look at this, it's a genomic ranges object for the first pair. You have this many numbers. You should have the same number for the second pair as well. So yeah, so we have almost 600,000 rows here. So now that we have two genomic ranges objects, so now we just put them back and then export them back into file. Okay, so you can use the pairs function and then give these two genomic ranges. So it will give you the hg38 bedpe file like this. Now you can use the export function from object layer and this one, and then save it into hg38 bedpe. So let's see. Okay, and if we go to here, now this is the new file that we just generated. So if you look at this, it will be the bedpe file. Okay, again, first anchor, second anchor, but now they're in hg38 version. Okay, as you can see here, this is a little bit actually complicated even for such a easy task. I mean, of course, you can always search online, Google, find, okay, there's a Python actually solution for this. Also using the UCAC utility tool liftover to do a similar task. Okay, I hope you find it helpful today, and we'll see you next time. Happy learning, and make sure you subscribe to the channel.